Natural selection acts only by taking advantage of slight successive variations. She can never take a great and sudden leap, but must advance by short and sure, though slow steps.
I'm a scientist, a biochemist, and biochemistry studies how life works at the level of molecules and also how life came to be the way it is. The standard answer for years has been that, well, we sort of evolved gradually by natural selection, but there are large problems with that.
Since 1988, Dr. Michael B. has investigated complex biological systems that seem to defy explanation by natural selection.
For the longest time, I believed that Darwinian evolution explained what we saw in biology, not because I saw how it could actually explain it, but because I was told that it did explain it. In schools, I was taught Darwinian biology. And through college and graduate school, I was in an atmosphere which just assumed that Darwinian evolution explained biology. And again, I didn't have any reason to doubt it. It wasn't until about 10 years or more ago that I read a book called Evolution: A Theory in Crisis by a geneticist by the name of Michael Denton, an Australian. And he put forward a lot of scientific arguments against Darwinian theory that I had never heard before. And the arguments seemed pretty convincing. And at that point, I started to get a bit angry because I thought I was being led down the primrose path. Here were a number of very good arguments, and I had gone through a doctoral program in biochemistry, became a faculty member, and I had never even heard of these things. And so from that point on, I became very interested in the question of evolution, and since have decided that Darwinian processes are not the whole explanation for life.
Michael Behe's skepticism derived in large measure from what modern biology has revealed about life's most fundamental unit, the cell.
In the 19th century, when Darwin was alive, scientists thought that the basis of life, the cell, was some simple glob of protoplasm, like a little piece of jello or something that was not hard to explain at all.
This perception didn't really change too much until the early 1950s. But in the last half century, our knowledge of the cell has just exploded.
Today, powerful technologies reveal elaborate microscopic worlds. Worlds so small that a thimbleful of cultured liquid can contain more than 4 billion single-cell bacteria, each packed with circuits, assembly instructions, and miniature machines, the complexity of which Charles Darwin could never have imagined.
At the very basis of life, where molecules and cells run the show, we've discovered machines, literally molecular machines. There are little molecular trucks that carry supplies from one end of the cell to the other. There are machines which capture the energy from sunlight and turn it into usable energy.
There are as many molecular machines in the human body as there are functions that the body has to do. So if you think about hearing, seeing, smelling, tasting, feeling, blood clotting, respiratory action, the immune response, all of those require a host of machines.
When we look at these machines, we ask ourselves, where do they come from? And the standard answer, Darwinian evolution, is very inadequate in my view.
Many of Behe's doubts were tied to a remarkable biological motor.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called a bacterial flagellum with all of its parts in all of its glory. It had a propeller and the hook region and the drive shaft and the motor and so on. I looked at that and I said, that's an outboard motor. That's designed. That's no chance assemblage of parts.
Behe's reaction was not surprising, for the molecular motors that drive bacteria through liquid each depend upon a system of intricately arranged mechanical parts. These parts come into focus when portions of a cell are magnified 50,000 times. Biochemists have used electron micrographs like this one to identify the parts and three-dimensional structure of the flagellar motor. In the process, they have revealed a marvel of engineering on a miniaturized scale.
Howard Berg at Harvard has labeled it the most efficient machine in the universe. These machines, some of them are running at 100,000 RPMs and are hardwired into a signal transduction or sensory mechanism so that it's getting feedback from the environment.
And even though they're spinning that fast, they can stop on a dime. It only takes a quarter turn for them to stop and shift directions and start spinning 100,000 RPM in the other direction.
And just like outboard motors on motorboats, it has a large number of parts which are necessary for the motor to work.
The bacterial flagellum, 2 gears, forward and reverse, water-cooled, proton motive force. It has a stator, it has a rotor, it has a U-joint, it has a drive shaft, it has a propeller, and they function as these parts of machines. It's, you know, it's not convenient that we give them these names. That's truly their function.
Since its discovery, scientists have tried to understand how a rotary motor could have arisen through natural selection. As yet, they have failed to offer any detailed Darwinian explanation.
Darwinism was a lot more plausible when we were thinking about globs of protoplasm than it is when we're thinking about molecular machines. Scientists in Darwin's day were hopeful that the complexity of biology would resolve to simplicity once they found the basis of life. But we found out the exact opposite. And in the 20th century, we found out that the lower you go from whole animal to organ to tissues and cells, the more complex life becomes, and that the very basis of life, the cell, is just outrageously complex. And so the 19th century hope that life at the bottom would be a simple phenomenon is spectacularly wrong.